Welcome to this tutorial and this video. In this video I want to give you like a preview or a tutorial on implementing tiny machine learning on an Arduino Nano RP2040 Connect. So this is a small device that can run machine learning. So we call this tiny machine learning. Tiny machine learning is actually one of the fastest growing field of machine learning right now. So we have various algorithms, hardware and software, but the critical thing here is that our devices, some of the devices, especially the IoT devices, have low power and they are always on. Probably they are battery powered. So tiny machine learning is this now field of machine learning now that takes these models or these algorithms that are working very well in very big machines and then making them work on small and tiny devices. So this will be a tutorial, and I'm using a platform called Edge Impulse. So this is a platform that has been developed to help us do this very easily. So before we go further, I want to introduce you to the microcontroller we are going to work. This tiny machine. It's an RP2040 microcontroller. So this microcontroller is the one used in an Arduino RP2040 Connect. So it's based on an ARM Cortex M0 microcontroller. It has good features actually. It has some 264 kilobytes of SRAM. It has a DMA controller. It has several input-output pins for various sensors. And the good thing with this board, this is a board based on this chip. It has several sensors. It has a microphone. It has an IMU, gyroscope, inertial measurement unit. It also has various sensors. It has a temperature sensor, so you can use this to do some machine learning experiments and even deployment. So this is the board we're going to use. So Edge Impulse, the platform we are using here today, is an optimizer. So it's an AI optimizer for edge applications. So it can optimize large models and then deploy it to any edge device with in a very simplified manner. So if you have an edge device, you can use this platform to collect data, design the model or the algorithm. You actually need very little knowledge here. It does most of the work for you. You can test and then deploy it on the edge device. So it does so much for you that you don't really struggle, you don't sweat. Okay, so Edge Impulse workflow, this is like what it actually does for you. So from the data collection, data analysis, digital signal processing pipeline, it does this something maybe you won't know if you are not a very technical person. It does the machine learning design and training. It estimates and evaluates the model. And then actually what it does for it to run on a tiny machine is the optimizations and compression of the model. And then after this, it converts and compiles the model to simple C++ code that can be run on an IoT device. So further, it can actually do IoT device management and also production monitoring. In fact, we call this TinyML operations. So TinyML ops. So it's like an operations workflow from the beginning to the end. So it's actually a cycle. So you go from step and then back and forth until you have a production device or a production model. So you can see it's doing a lot for you. It does the collection, the development, and deployment, monitoring at various levels for hardware, software, and the hardware software co-design. So it's a very powerful platform that we're going to explore briefly. It does much, but this tutorial will just serve as a preview. So it has some officially supported microcontroller targets listed here as well as on their website, but in this case we are especially working with RP2040 based boards. We have the official Raspberry Pi Pico, which is the board that has the RP2040 microcontroller, and we have the Arduino RP2040 that I'm using in this tutorial, and all these other ones. So you see on these boards there are various features, and they are very cheap, so you can acquire them very easily. And so let's get into the setup of the environment. First, you need the Edge Impulse installed on your PC. So you need the Edge Impulse command line interface, a CLI. It's used to control the devices, and it acts as a proxy to synchronize data for devices that don't have internet connection. So if you have an Arduino that has no Wi-Fi, so you can actually connect this to the PC, and then it sends data to the online platform for Edge Impulse. And of course, when we talk about tiny machine learning, the machine learning is running on the device, but the training is happening on the platform. So what Edge Impulse does, it doesn't run the model on the cloud. It actually does all the optimizations and gives the tiny machine the ability to run it on itself. So the CLI has several tools, seven tools. So the most common, the most used one for our case will be the Edge Impulse daemon. It configures the devices over serial, and it also acts as the proxy for devices that do not have an IP connection. So you can explore all these others. The other one that is very common is the data forwarder. So if you have your own board, not among the supported one, and you want to upload your data to Edge Impulse, you can use this data forwarder. So its description is given in the website. I also encourage you to visit their website. I will show you the website later. And then so this is how the installation goes. First, you need to create an Edge Impulse account. So once you have an account, you will have a username as well as a password, and then your host PC need to have an installation of Python 3. So latest one is preferred, so you install Python 3 on your host computer, and then you need to install Node.js version 14 or higher on your host computer. So, and then there's a note that for Windows users, when you are installing Node.js, during the process of installation of Node.js, there's a prompt that comes that requires you to automatically install the necessary tools. If you skip this without selecting this option, maybe later you will find some challenges with the installation. So remember to select this option before you install the CLI tool. So upon finishing this, you open the terminal, the command prompt. For Windows users, you can also do this in Linux. So you write this command, and then it will just install the Edge Impulse tools for you. So after this, now this is like the connection between the device. When you are now doing the design or the data collection, this is how you connect to the Edge Impulse cloud or the platform. So in our case, we're using the Arduino board, which has RP2040. So you have the board, and then you need to download a firmware for which that supports some firmware that is meant for the RP2040 microcontroller. I will show you how to do this, and then you connect it by your USB cable to the PC, and then you will initiate a connection to the Edge Impulse. So this is the process I'm going to show you shortly. So this is how it happens. You connect your board to your computer. For this board that we're using, you enter the bootloader mode by connecting the recovery pin. It's indicated on the board as REC pin. You connect it to ground and press the reset button briefly. What will happen is actually an external USB mass storage will appear on the PC, and then you drag the downloaded Edge Impulse UF2 file firmware that you download from the website, and then you drag it to the USB device that appears, and then that's it. You have your Edge Impulse loaded on the microcontroller. Okay, so after this, you're able now to connect to the Edge Impulse platform. So on the terminal, you just enter the Edge Impulse daemon, and then you will be required to select the COM port where your device is connected. You can find this in the device manager, and then once it's connected, you will enter your username as well as your password, and then you will be required to name the device, and the device you can name it as you wish. In my case, I renamed it as RP2040, and then the connection will be successful. So after this, you will just have to go to the platform and then begin your experiments, and this is the next step. So we're going to do a hands-on walkthrough on how to work on Edge Impulse. In this section of this video, I want to take you through the workflow of Edge Impulse, how to do a project, and then all the way from the design, data acquisition, design of the impulse, the training, the optimization, and even the deployment of the model to an embedded device. So at you go to Edge Impulse and then you log in. So you enter your username and then your password. So at the dashboard, you will create a new project, but in this case, the project I'm working on is the speech recognition. I'm going to classify 3 words, that is red, green, and yellow. So this is the project I'm working on, so I'll open it. So this is like the dashboard. It gives you a summary of this project. So already I had done it and done some steps into it, but here you find the summary of it and also links to other tutorials and other materials and documentation. So here you find various sections, the summary of the project, how much data you have, how many devices you've connected to this before, and then you have various other parameters you can check, but now this is not very important for now. Then so the first step when you have a project, machine learning project, you need data first. So, and before you acquire data, you need the device to acquire data, and it's preferable that you take the same device you're going to use for inference for your data collection, but not necessarily. So in this case, we are using speech. The Arduino RP2040 Nano has a microphone sensor, so we're going to use this for, already we have connected in the previous section, so you can check if it's listed in the devices connected. So I'm using RP2040 firmware, so you can see it has inbuilt microphone, so it's indicating green, meaning it's already connected. So you have to have one sensor or one device connected, at least one. Okay, and then after this you go to your data acquisition. So here already I had acquired, for this task, the speech recognition, you need at least some good amount of data for training of the model, the machine learning model. And so I had acquired data for the 4 classes in this case, red, yellow, and green, but also I had a class of noise or background, so as to differentiate when the word is said or not. And so for every label, for every class in this case, I acquired like 40 50 samples. It's not too much, so 50 times 4, I had 200. So I will demonstrate how to acquire some sample data. So on this collect data tab, you select the device. In this case is RP2040. You select the label for the data you want to collect. So in this case, let me say red, and then a sample length. Because this is audio, you need audio of considerable amount to classify or to be sufficient to classify the word you want to speak. So in this case, around 22.5 seconds. This is 2500 milliseconds. So that's enough. So the sensor you're using, you have various sensors in this board. You have the ultrasonic ranger, ADC sensor, and many other sensors, but we are interested in using the built-in microphone. So it operates at a frequency of either 16 kilohertz or 8 kilohertz. So we will use the 16 kilohertz. So now this is the time to take your data sample. So the first thing you do, you need to have your sensor close to you, so that when you record the sample, it's clear. So you press the start sampling to tell you wait. Red. So I spoke the word red, and then it's reading the data, and then it's uploading. So in the client, in the command line, you will see what's happening. From the time you pressed start sampling, you could see on the command line interface on how the progress is from the time you started sampling, the reading of the data, and then the uploading of the data to Edge Impulse Studio. So once it's uploaded, it's in the data set. Now in fact, you can actually test and see what happened, or like you can listen to the data set, the data sample that you took. So you just press here and listen. Yeah, so then let me play it again. Yeah, so you have to do this for the number of samples you need for this project. So for my case, I took 200 samples, and the total time it took me, the total time of the data set is 8 minutes and 23 seconds. But also there are other ways of uploading data. There is data sources, various CSV wizard. You can upload data in various ways. So maybe I will explore these other methods in other videos. So for now, at least we have some data sets. Now once you have good data and you've actually confirmed that your data, for noise, you see there's nothing, simply noise or background noise or silence. So after doing the data acquisition, you move to the design of the machine learning. In this case, we call it an impulse, according to Edge Impulse Studio. So normally you find this as an empty area, and then you select blocks. So because this is an audio file, you do some pre-processing. You need to add a processing block, which is the time series data. Of course, this is the data we have. This is the data set. And then you insert a block. You select from these options. So in this case, you have audio. We have this male frequency cepstral coefficients. It's good for human voice classification. And when we have male filter bank energy features, so you have MFE spectrogram, and then there's sentient, and there's also you can use raw data, but in this project we have used the MFCC, which is the recommended. If actually you are not sure, Edge Impulse will like recommend, so you just add it. So what this block does is actually it extracts features from your data. So your data actually has so much information. So the MFCC in simple terms, it's just to extract take the audio file and then extract the features and then give them out of something like an image, so that it can be used in the classification. In this case, a classification, we're going to use a neural network. So simply this block, what it does is to take your input data and then give us an image of audio. So because we have audio, which is a time series data, like we have values for every microsecond according to the sampling rate. Now for this section, for the time series data, there are two parameters you have to check. Probably you will just take the default ones. Window size is how long of the audio you want to take at a time for feature extraction. And then if you have like 3 seconds of audio, how much of it are you going to consider in the extraction of features for one particular time? So in this case, I've used I have an audio file of 3 seconds, but I'm taking 2 seconds each time at steps of 500 milliseconds. Of course, this is my frequency that I used in the data collection. Okay, and then now you add a learning block. So after having the pre-processing, you get to the learning block, and then here you have various. You have classification, you have regression, you could have a transfer learning block, then you could have anomaly detection, and many other. You could have a keras classification keras for a particular chip. In this case is the brain chip Akida, but we don't have this. So we are doing classification, so we will add a classification block. So in this classification, the input to this classification is the output of this pre-processing block. That's why the input features are from this. So automatically it will tell you like these are what you get. Now once you insert this block, this other output feature block will just come automatically. Now we have 4 classes, as you can see. It is green, green, noise, red, and yellow. So to further define various parameters for these blocks, so there are these options in this case. So if you click on the MFCC, this is now like the interface for this block. You can now change various things. Probably in the first time you are doing this project, you may just leave all the parameters as they are. For example, for male frequency cepstral coefficients, there are various parameters. So this MFCC is like an algorithm that takes audio, this audio here, you can actually play it, and then it takes this audio and gives you an image of these dimensions and of this kind. So this is good for the next process. So you take these raw features and then you get this kind of processed features. So this is like digital signal processing process. So for a start, you don't need to adjust any of these parameters, but in a future video I may go into details of this algorithm. But again, this is what edge impulse does for you. So you don't have to really, if you are doing a simple project, you don't have to think much about this, because edge impulse will do this for you. So the other time I told you about the window size. So here you see, for a particular time, it's considering a window size of 2, all the way from here to this, and then it can slide all the way to the end. So for every window it takes new features. Like now you can see it's updated this window, features are out, and then you see that's how it updates the windows. So this is what you do at this. You can change these parameters, but at the moment we will not change. So for the first time you open this, you have to generate the features. So already they are generated, but after you select this block, you come click the features, and then you can generate features. It will take some time to generate features. Now in this case it's going to generate afresh, so let's wait. So it's taking some time to generate features. Of course, we have a data set of 8 minutes, and then we have 4 classes, and now based on the window sizes we have 400 windows. So I think for every sample that we took, it is taking 2 windows. So it's going to take some time to generate the features. So these features are the ones we input to the classifier for image classification. So you see here we have the features. You can actually explore these features. For example, you can zoom into this noise, and then you see this is the window and this is the features that it got. You can actually view the features on another window, but these are like what you can explore, and you can even play. So you can actually make sure that you have good data in this case. So once you have generated these parameters that you already, and then the generated parameters, the generated features are here, you can explore them. Now then you go to the classifier. So this is now what normally a machine learning engineer will do, but now Edge Impulse is doing for you. It has already defined a model, a convolutional 1D convolutional model. It has defined the layers for this. So if you don't know much about convolution neural networks, this is done for you. So you see the input is here. It has 1300 features, and then the output layer is 4 classes. So we have 4 classes of output layer, and then we have how long are we going to train, how many cycles are we going to train. So here you can input your parameters, like how long. So normally this is a parameter you tune to enable your classifier to be more accurate in some cases. So in default, the default number was 100, so I put it double to 200 epochs, how many times it will cycle through, so as to adjust the accuracy. So if you go deep into machine learning and deep learning, you will understand this further. So the learning rate is also there by default. Now, but if you also want to tune this model further, there's an expert mode. You can switch to the expert mode. So this is what normally a machine learning engineer will also do. He will go import TensorFlow, because behind this platform, the TensorFlow and Keras packages are used. So you define the layers, you define how many epochs. Already now it's 200 here, how many, the learning rate, the batch size. These are the parameters you'll have to know if you are doing machine learning. And then which layers, the max pooling, the reshape layers. Then it defines all these until you find your model. So after you've defined, you can go back to the visual mode. Yes, switch back. So once you are satisfied with this model or this impulse or this classifier, then you start training. So once you have this, then let's click start training. So this is a process that will take some time. So depending on the training, the number of epochs you've defined, and how much data you have, this will take some good amount of time. But because again Edge Impulse is using a powerful GPU, cloud GPU, so this may take a lot of time. Already it's already at 100 epoch out of 200. So we will just wait for its results. So it's converting. So what it does actually, after training, we have a model, and this model is actually big, so it cannot fit on an embedded device. So what it does, it performs some optimization, and then it takes the TensorFlow model, converts to a TensorFlow Lite model, and then further optimizes it for it does what we call quantization into integer 8. So the integer 8 is a data type for very nice for low precision microcontrollers. And then after this, it does many other optimizations. Then it gives you a very light model. So after this, it has performed it also does some validation. So you see, our model, based on our parameters, it has achieved 100% accuracy based on the data we gave it, so that it's able to classify every of the data we gave it correctly. Of course, now this is at the performance of this training. It's interesting, but really sometimes you get 70s, 90s. So this is interesting. You can get very good results from your data. So it has good accuracy. Sometimes you can also be careful. 100% is not a very sometimes it could mean that your model has overfit, meaning it has crammed your data, and so you should check this. So what we will do, so after this, we can now move to the next step. So you have our classifier. So the other various things, so we can do some live classification. So before we download the model to our device, we have it connected already, so we can take a sample and then classify it. So let me take a sample. I will speak red. So I've spoken the word red. It will read the data, upload the data, and then it will do a classification. So it's classifying the data. Okay, you see, it has been able to classify this as red. You see, this is the confidence it has that it's green 0, it's noise 0, red 2. So the expected outcome was red, and then it did actually give us red. So we have red. So actually you can do more tests, and then at the end of it, it will give you the test results. So we can also try some other sample. We can take another sample, maybe take green. So I have spoken the word green, so it's reading the data from the device, and then it will upload the data and then classify the data. So remember, I spoke the word green. Okay, yeah, so you see the classification is correct. It's the word green, so that's what we expected. So this is the classification. Now again, we can still do another one. Now let's give it a noise, just speaking nothing, and it will read nothing. Okay, the noise, and then it will upload the data from the device, and then upload it and then classify it. So we expect noise, and indeed it has been able to detect this noise actually. So though there is some, the confidence is not so confident because we were actually speaking and it was silent. Okay, it was torn between noise and uncertain, but it's still noise, so it was correct. And then you can actually do more testing before you actually before you are confident that this model is accurate. So far we can also try yellow. So we have taken the word yellow, so it's doing its reading of the data. Yes, so it will classify this and then it will give us, yes, okay, it has given us the confidence of 2, so we are correct. This is what we expected. See, it classified this correctly. So this is the classification result, and now you can move to, you can come and check model testing here and see. So from the data we gave it, we can actually do a simple test for this data. You can just come here and then press the classify all. It will do some testing, so you should have more data for testing. So at this moment we will just, yeah, so ideally you should divide your entire data set into for training, validation and testing. But what we have put for testing is so little, but on an ideal case you need much more data to test your model. So let's see its output, the test mode output. Okay, nice. So here we have it. So according to the testing, you remember there was only one voice. It was uncertain for one thing. So see, we have, according to the testing, the accuracy is 87.5%. This is not bad. So you see, based on the samples we gave it, it was 50% sure of the noise, half, but it was 100. This is like, it's called confusion matrix, so that tells you how accurate it was for every class. And then you can perform calibrations. These are more complex procedure, so maybe I will explore it some other time. So now you need to go to deployment. So this is the point at which you now either deploy your model to a certain platform or a certain board. So because we are using the Arduino Nano RP2040 Connect, So the best option for us is to download an Arduino library. So this library, you just install it in the Arduino and then run the code and upload the code to their board, and then you just run your inference. So there are various options. You just check here. So if your board is not selected here, you can just make the Arduino library, or you can actually have a C++ library, or you can also have a TensorRT library for JSON if you're using JSON Nano or any JSON board, or if you're using BrainChip, all these others. So in this case, we're using Arduino library. You click, you select, and then you come at the end of this page. There's build. It will build now. It will generate some file, and then it will download this file, and this file is what you use to upload to your board. So this is taking some while, and then when it's done, it will give you the instructions, right? So the Arduino library is built. It tells you when you open the Arduino IDE, you go to the sketch option, include library, and add the zip file. It's already downloaded. You see it's here. So after this, you just go to the downloads, and then okay, the Arduino IDE, include it, and then we just